Assalamualaikum. My name is Nafati Fatiha binti Al Faisal, and in this video I will explain the meaning of differentiation and what are the techniques of differentiation. Differentiation is the process of finding the rate of change of a function. There is 6 techniques of differentiation in this video. First of all, power rule. Power rule is used when we differentiate a term that has variable raised to a power. The rule say if y equal to xn, the power n, then dy over dx equal to n x, the power of n minus 1. In simple word, bring down the power and then subtract 1 from the power. And then we have constant rule. The constant rule is very simple. If the term is just a number without any variable like y or x or z, its derivative is always 0. The formula is y equal to c, then dy over ds equal to 0. And then we have product rule. We use the product rule when two functions are multiplied together. The rule say dy over dx equal to u v prime plus vu prime. It's easy. You just need to keep the u and differentiate the v1, the v prime, and then plus keep the v and differentiate the v prime. And then let's move on with quotient rule. Quotient rule is used when one function is divided by another. It's same like product rule, but it's a little bit different because we have over v2, v the power of 2, and then the placement of this and this a little bit difference. The quotient rule, dy over dx equal to v u prime minus v u prime over v the power of 2. Next, we have chain rule. The chain rule is used when one function is inside another. Simpler word, differentiate the outer function, then multiply by the derivative of the inner function. The outer function and inner function. That's all. And then last but not least, sum and difference rule. Sum and difference rule is quite the same, but the difference of this is plus and minus. This rule is used when we are differentiating two or more functions that are added or subtract. The derivative of a sum and is the sum of the derivative, and the derivative of the difference is the difference of the derivative. So, in conclusion, by mastering this technique, we can differentiate almost any function we encounter in calculus. That's all from me.
Assalamualaikum, my name is Nurul Alia binti Adnan, and in this video I will be presenting question 2, which focus on the real life application of differentiation. For question 2, we have to find dy over dx for the following function. So the part A, we are given y equals sin 3x over ln x plus 1 minus 8. So to define this, we use the quotient rule, which is this formula. This formula is v u prime minus u v prime over v squared. The first thing, we have to find value of u prime and v prime. After we differentiate u and v, we have to find you have to apply the quotient rule. So this is the formula for the quotient rule. And then we substitute everything in this formula. So we got v, this is the value of v and u prime, u and v prime over v squared. So after we've substituted everything, so this is the final answer for this question. Next, we have to go the part B. The part B, we are given y equal x to the power of 4 cos 2x to the power of 3. This is a product of two functions, so we use the product rule. So the product rule, this formula is u prime v plus u v prime. So this next step, we have to apply the product rule. Is u prime, we have to differentiate v prime and v prime. After we differentiate, we got this value. So we just apply the product rule and substitute all the parts, and we got this u prime v plus u v prime, and this is the last answer, 4x 3 cos 2x to the power of 3 minus 6x to the power of 4 cos 2x to the power of 2 sin 2x. So this is the final answer for this question.
Assalamualaikum. Hi, I'm Nura Hasana, and I will explain about question 3. So there's given one equation to solve using the implicit differentiation. So the equation is here. So the first step is differentiate both sides, the left side and the right side, and then substitute everything in one equation, and then you need to moving all dy over dx on one side like this. So it will be a bit long equation, and then factor out the dy over dx, simplify the equation just like this, and then you will get the answer like this, and it will solve. The answer is dy over dx equal 2x second squared in bracket x power of 2 plus y power of 2 plus ye the power of xy over 4y the power of 3 minus 2y second squared in bracket x squared plus y squared minus xe the power of xy, and you'll get that answer. Thank you.
Assalamualaikum, my name is Muhammad Amirul Aiman bin Muhammad Zari. This is question 4 for set 3. Question 4. Use differential to estimate the value of 49.02 to the power of 3 over 2 minus 49.02 to the power of 1 over 2 minus 8. Give your answer correct to decimal places. Our x value is 49.02 and our value of x naught is 49. To determine of value of x naught, we estimate the easy number of our x value with no decimal places, which is we get 49. From this question, we can get this equation that is this function that is fx equal to x to the power of 3 over 2 minus x to the power of 1 over 2 minus 8. And we different our function, that is we get f prime x equal to x over 2 x to the power of 1 over 2 minus 1 over 2 x to the power of negative 1 over 2. To different this function, we times to the in front number and minus 1 power to the function, and we get the derivative function of this question function. To solve this problem, we use this formula, and the formula is f x naught plus delta x equal to fx plus f prime x times delta x. To determine delta x, we use this formula, that is delta x equal to x minus x naught. We just substitute the value of x and x naught into this formula, and we get the delta x value, that is the 0.02. To solve this problem, we substitute all the information that we have, x naught and delta x, into this formula, and we got this solution. After we substitute all the value, we get the answer for this solution is 328.21. To determine whether our answer is correct or not, we calculate again our question, that is 49.02 to the power of 3 over 2 minus 49.02 to the power of 1 over 2 minus 8. We get the exactly same answer, which is 328.29. And our solution for this question is correct, because both we got the same answer. Thank you.